everybody, and welcome back. Okay, now we do restoration and remediation. In other words, after the damage has already been done to the environment in some way, especially underground for the soil here, now that we have done air and water. What happens? Does the problem stay there forever? Do we fix it? Or something else? Okay, let's talk about it. First, we have to talk about commercial real estate, which might seem unrelated, right? But that is kind of the bulldozer behind a lot of this stuff, right? So we can do another thought experiment here. So you imagine you are some CEO or head of a company, right? You buy a new building, you move your employees in, and then they start to get sick, right? So they report symptoms. Vomiting, dizziness, lightheaded, they're feeling nauseous, sick to their stomach, right? Whatever it might be. And so you hire somebody to come out, right? In this case, it would be like a consultant that you would hire, an environmental scientist. And they come out and they do some research and they do measurements and they figure out that there is a big underground, like, fuel storage tank underneath that building, right? Because it used to be a gas station 100 billion years ago, right? And then it was just left down there and abandoned, left to rot and leak, and now the fumes are coming up and making your workers sick. So what do you do? Okay, so to be clear, there is a huge interest on the part of individual people and the government in making sure that that scenario does not ever happen, right? That whenever there is a commercial real estate transaction, there has to be some sort of assessment of whether the property being bought is hazardous. It is part of the due diligence on the part of the seller to show that the property they are selling is uncontaminated. And this is where a lot of the environmental business actually gets done, right? So leaking toxic fumes and gasoline, just to kind of visualize what that might look like, right? We have some sort of pollution source, and it gets down into the groundwater, and where it flows from there tends to be in all directions, but especially in whatever direction the groundwater might have been flowing in, right? So they call these plumes or contaminant plumes just because they make this kind of broad shape. Notice, right? So this is highest concentration closest to the source, lower concentration further from the source, tends to spread outward, travel along with the groundwater here, right? So then your employees who are right here are going to be getting a ton of fumes and other really horrible things that are leaking up and coming up through the soil and water. It's not good, right? So this is a situation that calls for some sort of restoration or remediation, or at the very least, recognition of the problem. This is where a lot of the environmental science business actually is, and where a lot of folks encounter the environment or environmental science in the context of the real world. You've got some sort of commercial real estate transaction. As part of that, as part of due diligence on the part of the seller, they have to put together site assessments and make sure that the property they're selling is not contaminated in order to give buyers peace of mind. Everybody has an interest in these deals being good. It makes everybody wealthier. Everybody gets more stuff and better quality of life in the end. And to be clear, if you decided that you were going to go and be an environmental scientist, there's a huge percentage of jobs that would just be involved in this and on this side of it, right? And if something is found, if there is a problem, then there's kind of a number of directions that can go in, depending on how bad the problem is, right? So broadly speaking, right, we can put these into, well, I guess 4 categories, but really 3 categories, right? So notice, environmental quality goes up on our y-axis and time passes as we move to the right. So we've got some sort of destruction, right? In this case, it says mining, or it could be any other sort of industrial activity that tanks the environmental quality, right? Now, this is where we get to it and take action, right? Notice our trajectories, right? We can let things recover on their own, and sometimes this is chosen either because the costs are too expensive, or there's simply nothing to be gained, or because other methods are ineffective, right? They just don't work. Reclamation, we're going to kind of skip over for now. We'll talk about remediation, right? Which is more about containing the damage, right? Stopping the spread of it, making sure it doesn't get any worse, which happens frequently. Or total restoration, which is trying to get the environment back to the quality that it was, right? So you try to figure out what is polluted, right? We talked about plumes, right, and contamination, assess the amount of damage, determine whether to contain it, which is remediation, to treat it, right, try to get it back to normal with restoration, or to abandon it. There are many, many different ways that this can be done, depending on what is down there. Everything from, like, pumping water out of the ground, treating it, and then putting it back, right? It would be a pump and treat system is extremely common. Or it could be something more like installing groundwater wells in, well, we'll go back to our visual, in a kind of radius, right? So if you installed groundwater wells here, right, all around the site, and they were deep and they were collecting information, right, you could kind of contain this and make sure that it doesn't spread elsewhere. And that happens frequently as well as part of the real world. Typically, brownfield sites are ones that can be somewhat managed and recovered. Not so bad, very common. Superfund sites tend to be the most extreme cases in terms of damage, right? Brownfields are going to be by far the most common. We have probably looked at these in our lives, like you have probably seen a million of them. I have included some images, like from around the city of Phoenix here, as to what these might look like, but for the most part, in our everyday lives, we would see these as being like abandoned industrial areas, right? Extremely common, right? So a brownfield is some sort of land that was used for industry but is now abandoned and which only has a little bit of contamination, right? So it can be managed, recovered, and turned into something new. So it's extremely common for brownfield sites to be repurposed, recovered, reused, or sometimes folks will just buy a brownfield site knowing that there is contamination and then work around that, and there can still be a lot of value to be found there as well. You get extremely common, a million of these, which you'll see with the Superfunds is a much smaller number. Why? Because these are much worse, right? So these are the truly outlier sites, the ones where recovery, right, turning it into something new tends to be impossible, all right? So here is where we might have a target for restoration, in a lot of cases, trying to get things back to normal. Here, a lot of times with the Superfund sites is where you gotta kind of say that it's messed up and there's no fixing it and just kind of contain the damage, section it off, and make sure that people don't go there. Because it's sort of unfixable, and we looked at one of these before. So the old Motorola plant at 52nd and McDowell, where you have dumping of industrial solvents and other toxic chemicals, creates a giant groundwater plume that is essentially in the middle of Phoenix. And we can take a look, right, and see that these are fairly rare. This right here is just a map of all our different Superfund sites in the state of Arizona in this part of the country. Awesome. So next, for our final section, and probably the most fun one, I think, we cover environmental engineering and Arizona, or in Arizona, whichever you prefer.